This may look like a map of the world, but it is actually a map of our planet's atmosphere, and it has a very special line on it. Can you name that? 1, 2, 3. It's the Kármán Line. Let's learn more. The Kármán Line is the internationally recognized boundary between Earth's atmosphere and outer space. It's an altitude of 100 kilometers or 62 miles above mean sea level. To put this in context, commercial airplanes typically fly between 9 and 12 kilometers above the ground, while most weather balloons only reach up to around 30 kilometers. So the Kármán Line is pretty high. But why is it important? And how did it get its name? Well, let's take a step back in history. In the early part of the 20th century, there was a lot of confusion about what exactly constituted outer space. At the time, people were starting to explore the upper atmosphere, in orbit with balloons, rockets, and early satellites. But there was no clear dividing line between these activities and those taking place within the atmosphere. This created some awkward situations. For example, in 1933, a German pilot named Otto Lilienthal set a world record by flying an aircraft to an altitude of 53 kilometers. But because there was no official definition of outer space at the time, it wasn't clear whether or not he had actually reached it. Enter Theodore von Karman, a Hungarian-American aerospace engineer and physicist. Von Karman was interested in understanding the behavior of air as it moves over the surface of an object, which is known as aerodynamics. To study this, he built wind tunnels where he could simulate the flow of air over different shapes and then measure the forces that resulted. One day, von Karman was working on a project to test the stability of aircraft wings, when he realized something strange was happening. As the altitude increased, the air seemed to lose its ability to generate lift. Specifically, he found that at an altitude of about 100 kilometers, the atmosphere was so thin that conventional aerodynamic flight was no longer possible. In other words, if you wanted to fly higher than 100 kilometers, you would need to find a new way to generate lift. In 1948, von Karman presented his findings to the International Academy of Astronautics and proposed that the boundary between Earth's atmosphere and outer space should be set at 100 kilometers. His idea was widely accepted, and the United States Air Force officially adopted the Kármán Line as the standard altitude for determining flight records. Today, it's also used by the Federation, the International Aviation and Space Federation, and other organizations. So what makes the Kármán Line such an important concept? Well, at 100 kilometers above sea level, the air is about 10 million times less dense than at sea level. This means that traditional aircraft wings can no longer generate enough lift to support the weight of an aircraft. At 100 kilometers, any vehicle would need to travel at orbital speeds, about 27,000 kilometers per hour, to generate enough lift. This is much faster than the speed of sound, which is already pretty fast. At that point, it becomes more like a spacecraft than an airplane. To make matters worse, the air is also much colder at 100 kilometers. The temperature of the atmosphere decreases with altitude until it reaches a point called the mesosphere, which is located between the mesosphere. The mesopause is the coldest part of the Earth system, and the temperature there can reach as low as 100 degrees Celsius. All of this is to say that the conditions at 100 kilometers above the Earth are pretty extreme, and they make it impossible for conventional aircraft to fly. Instead, at that altitude, you would need a rocket or some other type of propulsion system to get around. So below the Kármán Line, 100 kilometers, we have airplanes, helicopters, drones, and other types of vehicles that generate lift using aerodynamic principles. Above the Kármán Line, we have spacecraft and satellites that use orbital mechanics and rocket propulsion. It's also worth noting that the Kármán Line is not a physical boundary. There is no solid object or event horizon that marks the transition from Earth's atmosphere to outer space. It's more of a theoretical line that helps us distinguish between two different regimes of flight. Just like there is no hard line between water and alcohol, both liquids, or between ice cream and custard, both deserts, the transition from atmosphere to space is gradual. But the Kármán Line is still a useful concept because it helps us classify flight records and guide aerospace design and engineering. For example, according to the a person must reach an altitude of 100 kilometers to be considered an astronaut. Likewise, spacecraft that are launched into orbit are considered to be operating in outer space. The Kármán Line is also used in aviation to define the boundary between the Earth's atmosphere and the vacuum of space. This is important for things like satellite navigation and communication because the signals that these systems rely on do and work well in a vacuum. Furthermore, the Kármán Line plays a role in determining the flight envelope of aircraft. This is the range of altitudes, speeds, and other conditions under which an aircraft is designed to operate. For example, the SR-71 Blackbird, a high-altitude reconnaissance aircraft from the 1960s, had a maximum operating altitude of 31 kilometers. By contrast, the Space Shuttle, which is capable of reaching orbit, had a minimum flight altitude of 126 kilometers. But perhaps the most important thing to note is that the Kármán Line is a testament to the legacy of Theodore von Karman, who was a key figure in the development of both aviation and astronautics. He was one of the first people to really understand the physics of flight, and his work laid the foundation for many of the aerospace technologies we take for granted today. And hey, did you know that Brilliant has a course on orbital mechanics? It's a great way to learn more about the physics of spaceflight in the Kármán Line. In this course, you'll learn about things like orbits, trajectories, and the perturbations that can affect them. You'll also get to practice your problem-solving skills by working through interactive exercises. The best part is that you do need to be an expert in math or physics to take the class. It's designed for people at all levels. If you're interested in learning more, check out the link below. Thanks again to Brilliance for sponsoring this video, and now let's get back to the show. Look, we live in a world where everything seems to be speeding up. Breakthroughs in technology are happening at an ever-increasing pace, and it can be tough to keep up. That's why I'm so excited to tell you about today's sponsor, Brilliant. Brilliant is an online learning platform with thousands of lessons in science, computer science, and math. They offer interactive courses for all levels from beginner to advanced. Whether you want to learn about solar energy or neural networks, Brilliant has you covered. I've been digging their electricity fundamentals course lately, and it's helping me brush up on my knowledge of DC and AC circuits. The lessons are fun and easy to follow, and they've helped me better understand some of the more complex concepts. Plus, it's a great way to learn on the go, since it works on all devices. Now, I know what you might be thinking. Another online learning platform, right? Well, Brilliant is different. Their interactive approach makes learning easy, and their courses are always up to date with the latest breakthroughs and discoveries. So what are you waiting for? Sign up for free today and start learning with Brilliant. Thanks again to Brilliant for supporting this video. And now, let's wrap things up. So there you have it, the Kármán Line, a boundary in the sky that defines where Earth ends and space begins. It may be invisible, but it's a vital concept for anyone who wants to explore the final frontier. From pilots to astronauts, engineers to scientists, the Kármán Line is a reminder of the incredible heights that humans can achieve. And hey, if you liked this video, be sure to check out our other videos about space and the universe. We've got videos on everything from black holes to the Big Bang Theory to the latest space missions. You're sure to find something that piques your interest. Thanks for watching, and I'll see you next time.